Hello, this is Alair again. I would like to, or I would like us to learn how to use joins in Polish package. So we will create just some dummy data or fake data that we are going to use to illustrate or showcase how to use joins. So the first thing we need to do is I have already imported the packages here. So let me add one more package that we are going to use, which is NumPy. We are going to import NumPy as NP. Just ship return to run that. And then here we will create 3 different or maybe 4 different data sets, and then we will join those. So let's say create student create data set. And so the first thing I will do here, we want our data to be replicated by other people. So what we can do is set seed and the seed here, I'm going to choose my number, my favorite number. And we are going to create a dictionary. And the dictionary, we will have the names of the students and then their grades. So let's say maybe this is English. Or let's not do it like that. Let's say let's say maybe 1. We are just going to make this one as a dictionary. We need the names of the students. And we can put in a list of name here. So let's say Qual, maybe Dan, maybe Ian, maybe Quad, maybe Get Which, maybe Almost, maybe Kur, Kure. So we have about 7 students. Okay, and then here we will say maybe English. And English we will put in grades as well. So grade And instead of doing it like that, we are going to just generate random grades. We want the random norm, and then we want the mean. So let's say the average is 85, and scale, standard deviation, let's say maybe this is 10.5, 0, and the size, number of students in this case, which is 7, and then maybe we want student ID. I should have started with this one. So we're gonna say random integers, random dot rand int. We want them as numbers. Low, high, size. Okay, so we're gonna say we will start with 1 to 7. Let's try this one. Okay, and then so this is 1. I'm going to copy this one to create another one, another set. Let's say this is 2, and then the names will be the same. We are going to change this one. Maybe this is mathematics, and maybe math is too hard, maybe 85, and the standard deviation is probably 16.5. I will add another student name here. Maybe we have another name, let's say Yulo. So the number here is going to be 8, and this is going to go from 1 to 8. So we have another thing that I will do. Instead of just having one subject, I'm going to add another subject here. Let's say maybe this is stat. Man, maybe they did good here. So class average was 88. Maybe standard deviation was 12. Maybe 12. And maybe we have maybe data science. Data science, let's say maybe the average was 75. Standard deviation was 14.5. Okay, let's have those. And then now we need to convert these to data frame or data frames. So the first one, which is the student one, let's say we want to convert it to data frame, and we will say student, no, pl dot data frame. We want this here, and we want to see, so let's print the output. Okay, let's see. Okay, so now we have, but this is, the ID is being repeated. So I think I didn't do it correctly. I will have to check that, but now we have this, but we are seeing values that are greater than 100, which is not true or correct. So we will have to do something about those. And so it's English that we need to manipulate. So we take the column English and we want to trim this. And the way we are going to do it is we are going to use, so I should have started with PL when, so we are saying when this year is greater than 100. When that is greater than 100, then we are going to make it to 100. Otherwise, we are going to just leave it as is. And so let's run this one first. Okay, we need to close that parenthesis here. And okay, let's see how many we have. 1, 2, 3, 4, 5, 6, 7. So we also need to round. So we need to round here the whole thing. We will round it just to 1 decimal place. Okay, so we got that done. And so let me check something here. Okay, low none size type integer. Okay. So this is not the best way to do it. So what I will do, instead of randomizing it, I'm gonna do, maybe we can do range. Range, we will do 1 to 9. Let's see. Okay, we will need to move this one up. Okay, that didn't work. Okay, so I'm just gonna put in a list of numbers. 1, 2, 3, 4, 5, 6, 7. It's gonna be 8. Now let's try this one. Okay. Now it's working. And then, so this is this one that we have changed. We need to convert the other one. So what we have to do is just copy that, bring this one here. This is 2. This is 2. And in the second one, we have mathematics, statistics, and data science. So we need to change when we are saying English here. We want to change that to mathematics. Okay, mathematics. ID. Okay. Okay, so I was wondering what was going on. I didn't change that. Okay. So let's see. So mathematics there. And let's see what we did there. Okay, we need to change. Need to copy this one. It's not a good idea to copy because you can easily make mistakes. But I'm going to break that rule. And so this is going to be statistics. It's going to be data science. Statistics. Okay, I made another mistake. Okay, so okay. Okay, so we need to close this here. So there's an extra parenthesis at the end. Okay. The round. Okay, we need to close this one. Need to close this one. Okay, let's go back. Yeah, we need to close this. And let's check to make sure we got everything correctly. Let's see. Okay, so this with this. So I'm supposed to use just one, put all these within just a single dot with underscore columns, but I was putting them in different, I was creating more like 3 different calls of dot with underscore columns. Okay, so this is this, but again, secrets to okay, so let me go back up. That's English. That's English. This here we have mathematics. So we have mathematics. We have statistics. We have data science. So let me comment this out. Okay, so for some reasons, English was showing up in this distribution, which is not correct. So let's see. Okay, so now we have 2 distributions, like 2 different data sets. This year, let me just change it to grades. Underscore 1. And then, so we know this year only has 7 students. This one has 8 students. So now let's see how to join these data sets. So we have different types of joins. We have the left join, right join. So left join, when you join 2 data sets based on the left. So Apollo is going to look on the right data sets and only join or pulls the columns that are also on the left. If it is right, then it's doing the same, like pulling whatever is on the left that is found on the right. And then if you are doing the inner join, then it is looking into both data sets, only joining those that are common to both data sets. And then you are using full join, it doesn't matter, it just combines those two data sets. So let's see how to join. So we want to join, and we will take, let's say, take the first data set, which is grade 1, and then here we will say dot join, and then the second distribution or data set, and on what do we want to join this on. So we have the name, which is common, ID, which is also common, and yeah, ID, student ID, and the name. So we can say join on, if we want to join on just name, and we can do this one, but here we have not specified how we are going to join. Is it a full join? Is it a left join? So let's see what we can get out of this. So when we do that, now we have only 7 students. So what this has done is doing a left join. So we can come here and say question mark dot join, or actually we need to say pl dot join. Let's see. Okay, so it's not. Okay, so that's not doing it. I wanted to hover over it and see. Let me see here. So I wanted to see if by default it is left join. But I think that's what it is doing here. And then, so now we can specify it and say how we're going to join it. We can say left join, and it's exactly the same thing that we did. Then we are going to copy this one. And here we are going to say how we will do right join. And now when we do the right join, we know the right data set has 80 students. And so it is joining to the right, but one student, which is Ojulo, is not on the left side, so he doesn't have English grade. So that's why it is showing us null. What about when we want to say full? So full is going to be the same as that right join. Come on. Another thing we see here is we have a student ID, we have a student name. So because there are 2 sets of names, one on the right, one on the left, and the ID on the right and on the left, then it is distinguishing those by adding name underscore right and student underscore ID underscore right. We can override this here by doing this. Call less, we're gonna say true. And then when we do that, it's just doing it on the column that we are joining on, which is the name. It's not doing it for the ID. Since the ID is also similar, so instead of just joining by one column, we can give it a list of columns. So here we want to join by both the name and student ID. And then when we do that, we no longer see that this showing that the student underscore ID underscore right, because we have told Polish to join on those two columns. So basically these are some of the joins. Another one that you may find interesting, but I usually work with the left join or right join or full join, those three. But there are other types of joins that you will see. For example, inner join, I mentioned that earlier. And inner join is just pulling those columns, those names that are found on both in both data sets. We can also do anti-joint, which is just gonna pull out what is not on one side, what is only on one side, not the other. So anti-join. Okay, so I'm getting an error. Oh, let me check, make sure I is spelling it correctly. Join, inner joint, semi anti-joint. So no, I made a mistake. Sorry, my bad. See, I put it in the wrong place. It's how, that's where it goes. Anti-join. And that's nothing there. What about semi-join? And semi-join, it's only pulling that English. What about if we do name and student ID? Okay, so that's not giving us anything, but it returns rows from the left in which the data, the joint key is also present in the right. Okay, so these are the names that are also present on the right side. Okay, and then when we did the anti-joint, which here returns all rows from the left frame in which the join key is not present in the right. Okay, so that is not there, but if we take this, if we copy this and move the data set, like change this one to be 2 and this one as 1, so that the data set that as an additional student is at the beginning, then we should see that being pulled out. Yeah, and we see this name being pulled out. So that is the anti-join. And these are the most, there is a cross joint, which it like returns the cross product or Cartesian product of all rows from the left frame with all rows from the right frame. But I'm not going to show that. These are the main joints that you will encounter or work with, mostly left, right, and full joint. The rest, mostly if you want to diagnose to see what is the difference between the two data sets. And so let's say we join it. So we're going to join, and then I will show how you can calculate the average, the class average, and using the mean underscore horizontal. And then we will calculate, let's say we gave students different tests, and now we want to drop maybe one lowest test grade, or so we will see how to pick the top K and the bottom K grades. So let me see where we joined earlier. Okay, this is the one that we are going to take. So this here we will just call it student grades. Okay, and we will take that, we will bring it down here. Student grade. See what we have. So this is what we have. Maybe we need to drop the student ID. All these other ones are floats. This is an integer, so maybe we can leave it in there. But we can rearrange columns. So let's rearrange the columns. So we will say select. And we want to start with the student ID. So we can say student underscore ID. And then we want to keep everything else as is. So we want to start with student ID, name, English, mathematics, statistics, and data science. So the way we do it, we say old, but here we need to exclude the student ID, because if we don't, it's going to be repeated. So before I do that, let's run this and see. So we are getting an error, and it is telling us that the name student ID is duplicate. It is possible that multiple expressions are returning the same default column. And we know, I have just mentioned that. So we need to exclude this by chaining on the exclude. And then we want to say, okay, keep all the columns except that column we have moved to the front. Now we have everything the way we want it. And we are going to say, so what we are going to do here, each student has all these 4 subjects. We want to find the average score of each student. So we will say we'll come down here and we will say that with columns, and we need to name it whatever we want to name it. So maybe we say average score or grade. Average score equal p dot, we want the mean horizontal to go across. This is just like a cross method in dplyr, and it's horizontal, and we want all. So this is where we are using the polar select. We want, but we want the float. We don't want the integer, we don't want the string. So we want the float columns to find the mean over. So let's run this one and scroll to the right, and we see here we have calculated the mean for each student. We can round this here by calling the round. Maybe we round to 1 decimal place. Yeah. So that is student, the first student qualifies 94.0%, 0.0%, and then followed by Newquat with 80.4%, and so on. So this is how you apply the mean underscore horizontal, calculating anything across. So we can also calculate, maybe we say median score, and this is gonna be per student, and so maybe you say median is median there, median. So median, let me check first, make sure we have median. So Polaris median horizontal. Okay, so median is just median. So let's say median. And we want all the float columns. Let's see if this is going to work. So that's not working. Okay, the reason why it's not working is I just call median instead of calling the pl.median. And again, so here it's saying invalid input for call. See, so we say float, and it didn't work, so we just need to select the columns. So what if we say, so if it doesn't want to work like that, so so let's say I don't understand why it's not working, so let's try again. Float. Okay, so we have to tell it exactly the columns that we are working with. So let's say English, mathematics, and I think this is not going to work. The name median call pass to lazy frame dot with column is. Okay, so that's not going to work, so let's leave that. And instead, can we, yeah, we have mean horizontal. Now I'm going to copy this one. So mean horizontal is there. Minimum, yeah. And then so max is also there. Max. So I need to change this one to be mean instead of median. Max score. And I'm doing this just for the sake of learning, not that I need them. Okay, and let's go to the right to see. Yep. Okay. So another thing I will do, I'm just going to leave that like that. Then I'll come down here. We want to unpivot. So our data is spread out where subjects are, each subject is a column, but that's not tidy. So we can unpivot, which is pivot longer in deploy or in R, tidyverse or R tidyverse. We have student dot and pivot, and when we say and pivot here, we want the index, and the index should be student ID and name, and then everything else we are going to pivot it. So variable name, what do we call the variable? We are going to call it subject or courses, and then value name, we are going to call them scores or grade. And now we have pivoted longer. So that's how you pivot it longer, or using an pivot method in polars. So we took it from when it was wider to longer, and now we can easily pick out the best scores, like at least 2 best scores per student and 2 worst scores per student. So we are going to name this one, let's say final, maybe final grades, just making something up. Let's print it out. And now let's calculate two best scores or grades, and we will do 2 worst or 1. Yeah, 1. Subjects are 4, so maybe 2, 2. Okay. So we take the final grades. Oops, sorry. We take the final grades, and then we are going to group by. Here we have a choice. We can group by, and we will group by both the student ID and name. So student ID and name, and then we will call the aggregation method, and we want all p all, and then we are going to say, so let's see, okay, we will say all dot top k by, and we want the score and how many. So here by is what we have said by score, and then K. So instead of saying K, we can say 2. And if we run this here, it's just going to give them to us in a list. But we don't want them in a list. We want to return a data frame. So in that case, we're going to call explode. Explode. We want to explode all columns, excluding the columns we grouped by these. And now we have found our top 2 best scores. So quality score 100 in English and statistics. Okay, so we copy this one. We want to see the bottom 2, which we can easily tell, but just for the sake of learning. So we group by and we say bottom K, and bottom K should be similar. And bottom K, so where is qual? So qual is there. Qual is not that bad. But these are the bottom K. So let me go and see Omot there. So Omot did fairly in English and data science. What about, so in mathematics and statistics, he did good. Okay. So basically, this is what I wanted to share with you all. Working with the join, like learning how to apply or work with joins in Polis package. We have seen how to apply different types of joins, whether left joint, right joint, full join, which I say are the most common ones that I use a lot, and that maybe a lot of data scientists or majority of data scientists and analysts use a lot. And then we also look at inner joint, anti-joint, semi-joint. And I mentioned that there's another type of joints called cross joint, which I did not showcase. And then we learn how to calculate the horizontal mean, that is, we wanted to find the average score per student, and we use the horizontal method, which is start with what you are trying to calculate, which is mean underscore horizontal, mint, which is minimum underscore horizontal, or maximum or max underscore horizontal. And then we learn how to unpivot the data, that is, make the data tidy, that is, put all the subject in one column and the score in another column. And we use the dot and pivot method from Polis. And then from there, we calculated the top 2 best scores. We identify each student's top best scores and also bottom 2 scores. And that's it for now. This is non-quantum insights, where we are bridging the gap between R and Python, helping data scientists and analysts leverage the powers of both R and Python. Thank you. We are focusing on Polis package. Take care. Have a good night. Bye. Oh, hold on. I saw a comment here. Let me see. Sorry, Aaron. I'm just seeing your comment. Thank you for stopping by. We appreciate your support. We hope you find these tutorials helpful to get you started in your data science journey, or to upgrade your skills if you are an experienced data scientist or analyst. Thank you. Please don't hesitate to leave us any questions. Share our videos with your connections, your group, your friends, and give us suggestions of what you want to see as showcase. Thank you. Bye.